Microsoft recently released its agentic framework, and it's been gaining a lot of popularity. This is an absolute beginner's guide to building AI agents with Math framework. So if you haven't built an AI agent before, don't worry. We'll cover all the basics of LLMs and AI agents before we dive into Math. We'll start with the basics of AI agents. We'll understand what agentic systems are, where do frameworks like Math fit in, we'll then set up an environment with Math, then we'll build the first AI agent. We'll then move on to function tools as AI functions. And as always, this is not just a theory course. Every concept is accompanied by a hands-on lab that opens up right in your browser. We give you partially written or broken code and ask you to fix it. And we'll validate and give you feedback instantaneously. This approach of challenge-based learning helps you learn more efficiently. I'll let you know when you're ready to start your very first lab challenge. Let's begin with the first topic. So, what is an agent really? Let's start with the absolute beginner's guide to AI agent. Let's start with something that we already know. If you were to ask ChatGPT a question, it gets back to you with the response instantly. So the chat in ChatGPT is the application. The GPT is the LLM or large language model from OpenAI. There are so many other models out there like Gemini from Google, Claude from Anthropic, etc. You ask a large language model a question and it responds back with an answer. As simple as that. The chat application that simply interacts with the LLM and returns a response is not an AI agent. That's just a chatbot. What if the application could understand the user's requirement, break down inputs, and identify the user's intent, create a plan to solve the user's problem, and interact with third-party tools, and take action on behalf of that user? What if this application could think, decide, and act? That's when it becomes an AI agent. The thinking part is the ability to reason through LLMs given a context. The deciding part is the ability to break users' query into multi-step execution and prepare a plan. And the act part is where the AI agent interacts with the outside world through APIs, through function calls, or tools, or MCP as we will discover later, and take actions on our behalf, like booking a meeting, or reserving a hotel, or even booking a flight ticket. So as you start adding more functionality to your agent, it would start getting bloated with multiple integrations, such as too much exchange of data with the APIs. And you require your agent to remember certain details. You want to be able to log all interactions so you can monitor things. You also want to be able to debug issues easily when things break. And all of that create a lot of code that leads to higher code maintainability. And your code ends up looking like this. This is where Microsoft Agent Framework comes in. It helps developers structure and orchestrate these agents. Just like how React helps structure UI logic, if you're familiar with front-end frameworks. So it provides structure for reasoning and planning. It provides reusable tools and skills to interact with the third parties. It provides capabilities to manage memory and context. It provides support for observability, logging, and debugging. And it helps you define a clear lifecycle for your agents. So an agent built with complex piece of code that looks like this would look like as simple as this with an agent framework like Math. So to summarize, what really is the difference between chatbot and an agent? A chatbot is basically your question in, answer out system. It responds. It doesn't think ahead. It doesn't remember what happened 2 minutes ago. It doesn't plan. It doesn't decide. And it definitely doesn't take actions on your behalf. It's reactive, not proactive. Agents, on the other hand, are like giving your chatbot a brain, a memory, and hands. They can think using LLM reasoning. They can remember past steps. They can plan a multi-step workflow. They can use tools to interact with the outside world. They can take actions instead of just, giving plain answers. They can work proactively to achieve the goal you gave them. Alright, so this section is about getting started with Math and getting the environment set up out of the way. But before you do so, It's kind of very important to answer one specific question, that what kind of an agent do you need? Because math offers different subclasses of agents which you might be interested in using. So it's kind of important to know that what each of these classes offer. So we'll briefly run through them, and once we're done, we'll dive in straight into installing the right kind of Python packages and pip packages, and once we're done, we'll set up the environment variables and build our very first agent. All right, so agents can be of many types, right? So you can have a general purpose agent, you can have a chat focused agent, and maybe you just need an agent which leverages some AI services within the cloud. In Microsoft's case, Microsoft has Azure Cloud, which offers a lot of different AI and or machine learning services, which you can leverage. So in simple words, if I have to say general focused, I would just say, maybe I just want to build an agent that answers not so specific questions. And when I say chat focused, maybe I just need an agent that automates a specific chat workflow. And for Azure AI services, maybe I just need an endpoint to my specific Azure AI service. So knowing your use case is kind of crucial. So this is the structure that Math offers. AI agent is the main base class and everything else follows it. So chat agent is specialized for conversation flows, and Azure AI agent is optimized to run Azure AI services. So chat agent is something that we'll be using excessively in our upcoming sections. All right, so very next thing we need to do is installation and setup for Python. Firstly, we'll create a virtual environment. In Python, a virtual environment is more like a sandbox. It's more like a bubble in which you'll install all your dependencies, all your packages. And once this virtual environment is activated, you'll go ahead and install the pip package for agent framework. Just make sure that you have Python 3.10 above installed. And after that, we need to set up our environment variables. So environment variables are very specific to what kind of model you're using. So in my case, I'm using GPT-4o Mini, and I have a OpenAI API key associated to that. But feel free to use your own models. And in a bit, I'll also introduce you to one of the Code Cloud's key products, because it's called Code Key. So you have one key, and against that one key, you can use multiple models. So let's get into our terminal and let's get started. All right, so I'm in my terminal. The very first thing I need to do is create a virtual environment. Next, I need to activate it. Just to make sure, I need to check my Python version, which is 3.13.9. We're good to go. And let's go ahead and install Agent Framework, and we are good to go. So let me introduce you to the code base. So here we have a couple of files. The virtual environment file is Python generated. I've got nothing to do with it. These are a bunch of folders which we'll be exploring in the upcoming section. Here's my .env file. It has all my keys. Python version is again Python generated, and we should have a requirement txt because whenever you're building a project, it's really a good practice to put all your dependencies within this file so that every single time you don't have to install packages haphazardly, you would have all your packages here with their versions. So it's kind of a good practice. So this is what we have, and let's get started with our very first Hello World agent using Math. All right, so let's go ahead and build our very first agent using Math, and here are the contents for this section. So we'll start with a basic Hello World agent, very simplistic stuff, and it would be more like an explainer video where I explain how you can provide a specific input to a particular agent and how you can fetch information out of that agent. Lastly, we'll conclude with a very important debate about agents with memory and agents without memory. But before that, let's recap the simplest explanation of an agent, and I hope you remember this diagram from section 1. So agents are something or an entity that can think, decide, and act. But formally, this becomes context, memory, and tools. So agent is an entity that has a prior context. And when I say context, I mean knowledge. It can be internal knowledge through instructions or external knowledge. For example, it can be a database, it can be a bunch of files. Memory is something that you choose to save, and most probably they're going to be your conversation threads. And tools, as we also talked about it briefly in the very first section, they're more like connector to the outside world. They really help you connect to third-party APIs or, third-party tools that you can leverage. So that's the goal for an agent. And here's a scenario for you. So we're going to build like a flight planner agent. And here's more like a widget of it. So let's say I shoot off a message saying, "Hi, my name is John Doe." The agent responds, "Hi, John, what can I do for you?" And I'm like, "I live in Paris and I would like to book a flight to London." So all the conversations after this message, I would like my context to be stored in terms of memory or whatever, but I would want my agent to know that my name is John, number one, I live in Paris, number two, and that I'm temporarily flying to London. So there are like three variables at play here. So how we can build a simple agent is by leveraging OpenAI Response Client. And what you see on screen is like a bunch of import statement. We're importing OS, which is more like a OS package for Python. You can leverage a lot of file system functions through it. Async OS, it just helps us, build async workflows, async methods, and .env sort of loads all of our environment variables in our current execution, which we can leverage through the following statement that you see. And the purpose is obviously just, to fetch out our keys securely. All right, so once you have your chat client in place, you need to hook it up into a chat agent. And if you remember from the previous section, chat agent is a subclass that specializes into conversational workflows. So you give it a set of instruction. In my case, I just gave it like, you can make it verbose, but I just said, you search for cheap flights, and that's enough for me. And I give it a name, and next I run the agent and I give my query to it. And it's pretty simplistic. So let's go ahead in our code and see this in action. All right, so I'm in my VS Code and here's my code. It's pretty much the same code. All I did is change a few things here and there. I added a new set of instruction for my chat agent, and it says you're an assistant that explains frameworks clearly. And I've named it ExplainBot. And my question that I pose is, explain briefly about Microsoft Agent Framework. So let's go ahead and run it and see this in action. So all I need to do is type in Python, and my file is basic-chat-agent.py. So we wait for a bit. It's going to do its async magic, and boom, here we go. So the agent reply is Microsoft Agent Framework is a software development platform to create interactive and animated characters agents. So you see what's happening. This is a mess and we need to fix this. So according to our agent, our simple agent, Microsoft Agent Framework does character animation, speech recognition, and synthesis. So it's still sort of a linear thingy, right? So it's not thinking through, it's being reactive. It's just, hallucinating and just giving me a response. That's a perfect example of what I wanted to show you. Like currently, I can say that this is just a glorified chatbot. And we need to fix it by adding in tools and memory and maybe, a couple of verbose instructions. So yeah, let's do that. But before we do that, I just want you guys to appreciate the fact that, chat clients and agent, there's a very thin line between it. And the only thing that really differentiates them apart from each other are tools and memory itself and the way we use it, obviously. But there's one more thing that I wanted to highlight, which I spoke about in the previous section, is this part here. So we need an API key and a model to build our chat client. But Cold Cloud has a product that you can use by the name of Code Key. And this here is a playground. And once you enter the playground, you can sign up for 25 API credit, which lasts for a month. Here you can select any model. So currently they have Grok, OpenAI, Google Gemini Pro, and Anthropic Sonnet 4. So you need to hook up a base URL, and alongside you get an API key, and you can use this API key. Obviously, you have to specify the model. So for example, if I were to do that here, I need to add in base URL, and I'm going to copy this URL over here. And this is something that I will be doing. I have already my model stated within my environment file, and I already have my API key there as well. So the rest is pretty good. So this is how you can structure a very basic agent, but there's a lot of work to be done. Let's move to the next section to actually improve our agent. So now we know that our agent does not have, complete knowledge about Microsoft Agent Framework, and we need to figure out how we can provide that knowledge to it. Maybe it can be a web search, or it can be a detailed document about Microsoft Agent Framework. But in any case, we need to provide that information to our agent so that it can figure out the right kind of answer. But let's do this particular activity where we, take that limitation to another level. So if you're building this agent with me, try these two prompts out, and maybe I can do that for you so that it can give you a better context. So let's jump into the code again. All right, so I'm back in my code, and I change the instruction and the name again. So the instructions are, you're a helpful assistant that keeps tracks of my day, and it's just an assistant. And here are these two prompts. So let's go ahead and run it. The very first prompt is, my name is John, and the next one is, I prompt the agent like, what's my name? And I would type in Python, basic agent py. So the very first reply is, nice to meet you, John. How can I assist you today? But the very next answer is like, I don't know your name yet. How would you like to be addressed? So this is a problem, and this is a problem that I wanted to address. So that is why memory actually matters, because without memory, every agent is a dumb agent. Every interaction would be fresh. But on the hinge side, we need our agents to remember our conversations, remember our preferences, even our personal information to a certain degree. And this as a whole, that's what we call context. All right, so let's talk about when memory is a bit too much. And this question sort of resonates with the very first question I asked during the start of this section. And that's something like, what kind of an agent do you want to build? Do you want to build an agent that is a bit, chat focused, or a general purpose agent? So if you're building a general purpose agent, which doesn't require a lot of knowledge or, a lot of interactivity with the outside world, then it's pretty linear. It's more like a linear chatbot, which is stateless and answers, just specific questions like the weather in a particular country or a city. Tell me about the culture for a particular country. We can pose such question to such a general purpose agent. And that's where memory is a bit too much. You don't need it because there's no state to be saved. So hence, we really need to discriminate between when to use memory and when not to use memory, what kind of an agent we're building, and what kind of an agent would actually use memory or tools. So yeah, choose wisely. Alright, it's now time to access the first lab challenge. Use the link in the description below to enroll in the labs. And these labs come free of cost as a part of this video. All you need to do is create a free account and click enroll. Once you're in, you'll see all the labs listed on the left here. So you can follow along with me. Let's start your very first lab. And your mission, if you choose to accept it, is to build your very first AI agent. What you see on the left is more like an instruction panel. You would see some summaries about the content that you've covered, some newer concepts, but mostly instructions about your tasks. What you see on the right is a whole VS Code setup where, you get the whole thing, you get the whole experience, and this is where you'll actually code. So here we have a series of tasks listed right here, and I'll walk you through each one of them as we go. So yeah, let's get started with the very first one. Okay, so most of the stuff you see here is you've already covered it. So it's kind of a good refresher if you walk through it. And once you're done, click OK. Okay, so environment setup. So if you remember, I talked about, sandboxing your project. So in Python, it's a good practice that you sandbox your project, create a virtual environment, operate within that virtual environment, install all your pip packages and requirements as you go, and execute within that environment. So this section is all about that, and this particular line that you see, which says run this first, we'll copy this, we'll paste it right here and enter. So as you can see, success, environment setup completed. So this particular command actually ran this file. So this file has a couple of checks, like check Python version, check virtual environments, and we've got a series of methods which were run. So all of them were to ensure that you have everything in place to complete these 4 tasks. So once you have covered this particular section and you get this message, scroll down and hit check. Perfect, so we're good to go. Okay, so this again is a refresher. So whenever you're building an agent, the very first thing you would do is create a chat client, which would have your model identification, your API key, your base URL, and then you hook that chat client within your agent. And for an agent, all you need is a name and instructions. And that's it. All you got to do is hit up agent.run and interact with your agent. So hit OK. Okay, so let's get our hands dirty. This is your very first task, and as you can see, with every task, let me clear this up and let's push this here. Perfect. So within this whole code, you have a couple of to-dos. Like here we have to-do number 1, and you have to replace some of the stuff that is listed in the to-dos. For example, in this case, it was a name, and here we have instruction. So let's copy this. Backspace. There we go. So these were to-dos for line number 33 and 34. So we have covered these. We have got another one on line number 47. So let's copy this, and here we go. Perfect. So we're good to go. All you got to do is copy this and bring back our terminal. Let's clear this up, paste, and run. Okay, so task 1 is complete. Perfect. Let's check this and move ahead. Okay, so up till now we have been using agent.run, but that is one way of executing an agent. But what if you need streaming? So what if you need, for example, if you're using an agent which sends a huge response, a lot of tokens, so you gotta wait for it. That increases latency for your agent. So to lower that, it's a good practice to use runstream instead. But runstream actually returns you chunks. So you have to gather those chunks, you have to display those chunks accordingly, and this is what this task is all about. So I'm gonna hit OK and move on to my next task, which is about streaming. Yet again, I have a couple of to-dos, like line number 42. So let's go to line number 42. Here, as you can see, instead of using agent.run, I'm going to use agent runstream. And line number 48, I'm going to use chunk.text right here. So as you can see, this stream initializes, the stream itself. But every stream returns some bits of chunks, which we're checking if chunk.text exists. You gotta print that here. And I think we're done. This was line number 50. Perfect. I'm going to copy this. Let's come over here, clear this whole thing, and paste. Yeah, so this is streaming in action. Beautiful. As you can see, this is a non-streaming response and it's taking a while. So the whole thing here took a bit of its time, right? So that's why whenever you're dealing with latency, it's kind of important to make sure that whether you need a streaming response or a non-streaming response. By the way, the task 2 is complete. Let's move on next. I'm going to check this and I'm going to hit next. All right, so next section is about, customizing agent behavior through instructions. So within instructions, you can play around with the tone of an agent. So it can be formal, it can be casual, it can be friendly, it can be technical. The same thing with style, expertise, and behavior. So here we have a couple of examples. Once you go through it, you would get a gist of the whole thing. So once you've read them, hit OK. And let's move next. So in our third task, we yet again have a few to-dos. So line number 44 and 45. So let's scroll all the way down. So here we're building a technical agent. And we have a set of instructions. Okay, so the instructions are: you're a technical support specialist for TechCorp. Use precise technical language, ask diagnostic questions, and provide step-by-step solutions. Format response with numbered steps. So that's one way of, playing around with the tone. So let's move on to 59 to 60. So here we have a medical advisor. So let's copy the whole thing. Perfect. Okay, so you're a medical information assistant for TechCorp Health. Provide accurate health information. Always include disclaimers. To consult healthcare providers and use medical terminologies to lay explanations. So that's another way of doing that. And you'll find a similar way. Yeah, so in to-do 3, compare the 3 agents' responses above. How did the instruction change the tone? So yeah, I think we can go ahead and run this as well. So let's bring back our terminal. Let's clear the whole thing, paste, and okay, so here we have a response and you can judge, the tone of each agent accordingly. So with that, your task 3 is complete as well. So I'm going to check this and we're going to move ahead. So in this section, we'll be talking about permanent and temporary instructions. So permanent instruction is something that we have already done. So it's something that you provide with the name, pretty straightforward. But additional information is more like per request context. It's more like steering your agent's behavior on the go while it's executing. So it's some of the common use cases as audience adaptation, length control, and we also have a certain example for you. So let's go ahead and click OK, and let's get started with our last task. So task number 4, let's get rid of this as well, and let's get rid of this as well. So line number 67, answer in exactly 1 sentence. Okay. Let's go and find line number 67 to do. We're going to fill this out here. So as you can see, we built an instruction and this was our agent. We just ran our agent with a particular query and this was our additional instruction. With experiment 2, we are running the agent again and we are changing our additional instructions. So it was different over here. It is different over here. Okay, so let's move on to line number 77. It's right here. And here we have yet again a different additional instruction. Perfect. So now we move on to line number 93 to 96. So again, reflection questions. Compare experiment 1, audience adaptation, versus experiment 2, length control. And how does additional information differ from permanent instructions? So with this, let's get back our terminal. Let's clear the response and hit run. So as the response is being generated, it would be great if you just go through it and just reflect for a bit and try to find the difference, and you'll notice the actual advantage of using additional instructions for specific queries and how they both actually operate together, and how you can find really, that sweet spot where you can use instructions and additional instructions together. Perfect. So that completes your section number 4. Hit check. And we move next. And with that, congratulations. You've mastered the math fundamentals. Alright people, so in this section we'll enhance our agent in terms of memory and context management. So we'll start with something like a simplest explanation for memory and context, specifically in terms of math agents. So we'll run you through 2 scenarios. And the very first one would be session level memory, which is also known as short-term memory, versus long-term memory. So we'll see a couple of scenarios where both of them actually fit in. We've been making a travel agent, a very lean one, a very simple one. So in this section, we'll be adding a layer of memory to it. And we'll see how we can do that in terms of, short-term and long-term both. We'll talk about threads, how they really help you preserve some conversational context. And lastly, we'll see how tools can really give superpower to your existing agents. So imagine you're talking to a friend. They know you, you know them, you guys share some common jokes, and both of you know the context of those jokes, the backgrounds of those jokes. You remember some of the previous chats that you have. So how can we introduce the same level of depth with an agent? That's where memory and context comes in. We need something that can store the relevant past interaction. And most of these interactions are just textual. So we're talking about, saving these texts somewhere and injecting them within, our upcoming prompts or future prompts so that an agent can answer us in a better way. Let's talk about session level memory. So math offers something like a thread, which introduces the state within an agent. So the diagram here shows that one agent can have many threads. So it can preserve all of those different conversations separately. And separately, where each of their context is preserved, where each of their text is preserved, the historical, conversations are preserved. So that's the target here. And eventually, when you store the previous conversation, they would obviously make sense when you're prompting a specific thread. So like one thread can be, a trip to Paris, and you drop in all kind of details within that thread. So that's what we're trying to achieve. So the simplest way to do that is, is the get new thread method that the agent offers. And all you have to do differently is whenever you're asking a question, you reference this thread at the very end. And the agent would take care of the rest. So let's jump into the code and let's see how we can achieve it with math. All right, people, so I'm back in my VS Code and I've made a few changes to it. So I'll just quickly run them by you. So this is my travel bot. The very first thing we did is, create a chat client, which is just something that, references our OpenAI model. I'm using GPT-4o Mini, and we hook it up into a chat agent, which happens to be our travel assistant. So I need to be a bit verbose here. So we call it travel bot. Here we create a new thread, and every single time I ask a question, I pass this thread within the run method. And here I'm just fetching stuff up. So here I say I live in Paris, and I expect this to be saved within this thread. And so the next time I ask in which city I live, the thread happens to have all the context, and it would reply in terms of that context. So let's run this real quick and see. So I'll just type in Python basic chat uh, agent memory.py. So let's see. Okay, the first reply is in. That's wonderful. Paris is such a beautiful city with amazing culture, history, and cuisine. And the second reply here, you mentioned that you live in Paris. See the change? So this is the session level memory. Now we don't have to start all over again. So we have some element that would remember what we have been talking about. So this is where threads are really handy and really help you in preserving the conversations. You can even store these threads somewhere, something like Redis, something like, a database even. Or if you just don't want to be, that fancy, you can just save it in a file and retrieve it later on and add the context within the chat itself. All right, let's talk about the long-term memory. So in Maps term, it's called context provider. So it refers to the information that your agent store or persists across multiple threads. So an agent can now have 1,000 threads and your information is scattered in these 1,000 threads, but we don't have a central body which would keep the most important aspects of those conversations that you had somewhere. So we need that central body. So in this case, that central body is the context provider. So we might need to save something like your preferences, stable facts about you and your environment, just like we followed the last example about traveling to Paris and knowing that you live in Paris and you're traveling to London. So it's more like having summaries of past interactions stored somewhere so that your agent can refer to those and answer you in a better manner. All right, so within MAF, you implement a custom context provider. So the subclasses are listed here. It's AI context provider and context provider itself. So they are responsible for the long-term memory. So every context provider offers you two methods that you can override. So one is before invocation and one is after invocation. So it's like when agent receives a prompt, the kind of stuff it does before, processing the prompt, and the kind of stuff you can do after you receive a prompt. So it's like, injecting context derived from persistent memory or the threads as we discussed, like users preferred language, users current location. And when you talk about after invocation, you inspect the messages from the user or the agent to fetch out meaningful stuff in it. And when you fetch those stuff out, you can store it somewhere. So that's how you can do it. All you need to do is define your memory provider. So in this case, I'm keeping the track of user's favorite color. And we'll see this example in detail. But I just want to show you how simply we can do that. So while defining the agent, we might need to state our context provider, when we initialize our chat agents. So let's get into the code. So I'm back in my code and I changed a few things. So let me walk you guys through it. This is pretty much the same as it was in the previous section. We create a chat client. We hook up our API key and model ID. The new thing I did here is I created a memory provider. So I'll walk you through this class in a bit. So now we use the async syntax to actually generate the chat agent. So within the chat agent, we hook up our chat client. We have changed the instruction. So it's like your friendly assistant asks the user about their favorite color if you don't know it yet. So pretty simple and straightforward. We hook up our memory provider, which is more like a black box right now, but we'll talk in a bit. So when I say async with chat agent, it's like I want to run this code asynchronously and I need to wrap this code alongside with building chat agent. So we create a thread here. It's something that we just discussed. This really helps us give that session level memory. And next, I have a few questions for my agent. So we hook up our thread here. And the question is, this is just a print statement, just so that I can present it to you in a nice way. So the very first prompt is, hello, how are you? We get our response over here. The second prompt is, I intentionally tell the agent that, my favorite color is blue. So I expect my agent to store, the favorite color here, into my context provider. So I print out my response here. And just to cross check, my third prompt to the agent is, do you remember my favorite color? So I print it out here again. And lastly, this is where my favorite color is saved within the memory provider. There's an object memory and I save my favorite color over there. And I'm just printing it just for the reference. Okay, now let's get into our favorite color class. So in order to store your favorite color, obviously you need a model. So I created a user memory model, which is being extended by Pydantic's base class. It's assigned to none or null, because it's Python. Here we create our custom context provider. So this is the color favorite color memory class that you see over here. And you see chat line being passed here. So this was our chat line. And we're receiving the chat line and we're just, sort of hooking it up within our, object. The next thing we do within the constructor is we create a memory, or if we have existing memory, so we'll just hook it up. But since we're not providing it any, this particular piece of code would create a new user memory, which would be favorite color, but with a value of none. So I explained it to you, whenever you extend through context provider, you get these two methods, which you need to override. So let's talk about invoking first. So before the agent responds, provide the context about what we know. So we'll just check that if, this thing is null or not. So if it's not, it holds a value. So we'll print that value over here. But in case it's not, we'll just, add an instruction, which is an output message that you do not have, user's favorite color yet. So once that is done, we can also override the invoked method. So this is what happens afterwards. So we have to check if user is saying something which might change the existing value of the favorite color. So it's like inspecting user's message. So here's a demonstration. We'll pass in, the request messages, which are like user's messages. For this particular instance, we'll check the role, like if it's a user, and if user says something like this, like my favorite color is, if user prompts something like this, we would want to, detect what that value is, and this here sort of breaks the message down and, fetches the value that is being stated by the user. So once we have fetched it, we'll just, sort of capitalize it and update the memory. So that's pretty much it. So these two steps are kind of important. Let's see it in action. So I'll just type in Python. Forgot the name of the file. So this is cd context. Cd context. And next I need to do, that's right. So hello, how are you? This shows, that the favorite color memory. Okay, let it generate first and then I can walk you through the output. Perfect. So the very first thing we did is whenever the user prompted, as you can see, the invoking and invoked method was, run. And this last line is from the invoke method because we are like inspecting the message for the user. So whenever the user drops in a new message, both of these methods would run. But again, the sequence of these methods are different. So the invoking method happens to be the first one, invoked is the last one. So so the assistant replies, hello, I'm doing well. Thank you for asking. How about you? By the way, what's your favorite color? The user asks, the user states that my favorite color is blue. Again, invoking was, invoking was called, invoke was called. And now when, invoked was called, we now have a value because the user used, these pattern of words. So that's why you see that, detected user sharing the favorite color. So updated favorite color to blue. And the assistant responds like, blue is a lovely color. Again, the user asks, do you remember my favorite color? Again, these methods were invoked, and while the invoking was called, now we have a value. So if you remember, there was a check in there that if the memory favorite color has a value, then you tell the user, or you just print out that the user's favorite color is the value which we stored in the memory. So pretty simplistic. And now we retrieve the favorite color. And yes, your favorite color is blue. It's such a nice choice. So that's how you can sort of use a combination of invoking and invoked to store the context permanently. Cool. Let's circle things back to the travel agent, but this time with memory. And I want you guys to appreciate the fact that adding memory really changes things dramatically and how it paves the way for tool integration. So let's say you prompt an agent like, I'm going to Paris next week. The agent would think, and it would extract all the right variables and store it within its context or memory. So the relevant variables here are obviously the destination Paris and date set to next week. Now, if you prompt the agent like, hey, find me a hotel, the agent would be able to use, some kind of a tool against these values, against the values that is stored in the memory. So maybe it can use a web search tool. So that's how, tool integrations come into play. So the agent used web search to search flight or hotels in this particular case to align with user preferences. So we needed user preferences, which were not a part of its, training data or not a part of its, internal context. So that had to come from the outside. Hence, we stored it in the memory. Now, the web search tool is here, which it uses to act and communicate with the outside world. But here's a problem. It would bring all the kind of list, of hotels that exist in Paris for next week. What if we just need one hotel? What if we just need to communicate about booking and, finding the right kind of suite in one hotel? That's how tool integration matters, because we might need to use a tool which refers to an API for a specific hotel. So that's how it comes into the play. So without tools, agent gives generic answers. With tools, it acts by calling a booking API, calendar API, you name it, any API. So MAF really offers the combination of tools and memory in a way where you can experience automation and personalization at the same time. So that is the cool factor. All right, people, so welcome to your second lab, and your mission this time is to master memory and context management. Obviously, you would want your agents to remember conversations, but obviously, agents can do so much. So you gotta manage how you can smartly handle the contextual part and provide personalized experience through your agents. So this time we have 4 progressive tasks for you. So you guys know the drill. Let's hit OK. All right, so this is yet again a refresher. We'll start with what is conversation memory and how your agents can actually remember previous messages. And that is done through threads, which we'll learn in this lab and implement it ourselves. So what is the difference between stateless and stateful agents? So the word state is at play here. And to inculcate a state within an agent, obviously you need some form of an element of a memory. And then, since obviously we are using LLMs in agents, so context windows and token limits are a huge, difference creator whenever you're building agents and whenever you're using agents. So it's not like you can ignore both of them. Then we have, different memory management strategies, and we'll apply all 3 of them within our labs. So let's go ahead and click OK. All right, so if you've gone through lab 1, obviously you're very well accustomed of what the environment setup is. So I'm just going to copy this and paste. And yeah, our environment setup is successful. Let's click check and okay, so this is task 1, and it's about how we can implement multi-turn conversations. So this is basically done through threads, and here we have a sample for you of the thread pattern and how you can create a thread, how you can attach a thread within, an existing execution of an agent. And here's another example, and yet again another example. So just a few, summary points for you. So once you're done going through them, click OK. All right, so let's begin our very first task. So let me walk you through it. We create our chat client, we create our chat agent, and then to do number one, keep the conversation state. So here, what we're trying to do is we're creating an agent thread. So this is more like a session long memory, and this is our object. So whenever now we will converse with an agent, we will hook this particular object into that method. Okay, so the very first turn is customer introduction. We have one message. Hi, my name is Sarah and I'm having trouble with my account. So here, as you can see, we have hooked chat history over here. So to do number two, we are trying with the new message and we'll be hooking up our chat history over here. And then to do number three, execute the agent with the current user message and its associated conversation state. So we have yet another message. What was the issue again? So for this, we'll copy message 3 and this goes here. And we need the whole thing. Thread is equal to chat history. So comma and chat thread. Perfect. So we had, I think we're done. Yeah. So what we can do next is copy this, bring our terminal. Let's make some space and hit run. Perfect. So our task one is complete. We can now move on. Let's clear the terminal. Okay, click check and next. Okay, task number 2, and this is going to be a bit tricky and a bit longer because we're dealing with conversations that got too long. So when we're talking about LLMs, we talk about its associated context window, which is a limiting factor. So you cannot dump all the data in the world and expect it to act consistently. So you have to manage that data. You have to manage that context. So here we will be talking about a few strategies. The very first one is sliding window, which is message based, which means that you save a particular amount of messages and recent messages and you let go of, the previous ones or slightly older ones. Then we have token based, which is, you keep messages that fit a particular limit of tokens. So here we have some, working remedies that you can apply readily. So here you access your messages, but you can remove your messages like these. This just means keep last in, which are like the recent ones. So this is sliding window at play. So let's get ahead into the code. Let's hit OK. Okay, so we have got a couple of to-dos. We'll start with line 37. Let me explain things as we go. So pretty simple stuff. We have chat client here. We have the agent here. Then on line number 37, we have, so we've talked about it in the previous, section. We will be creating agent.new thread. So this is for our session level memory. And next we move on to line number 82. Okay, so let's start with to do 2. So implement sliding window truncation. And as we go down, we're creating a new thread. We are creating a object, an array of object, or probably this is just going to be array of strings, I believe. So I'm filling it up with a particular message. So it is array of string. All right, so to do, extract only last 5 messages. This is something that we have done in our first to do. And then we go ahead and run the agent. So you'll see a couple of outputs over here. And now we ask the same question again. And here we have all our print statements. Perfect. So create another conversation with varying message limits. So here, I think we are, so we have a short message, then we have, slightly longer messages, and you can go through and read through each one of them. We're updating our message count over here, total exchanges right here. Then as we slightly move below, so we have an implementation of token budgeting. So our total budget, which is a part of to-do 3, so we're done here, and this is to-do 3 where our token budget or token limit is 1,000. So line number 141 is pretty simple, I believe, because all we have to do is impose this check right here. So with that done, we can go on to our line number 158, where messages in the budget, which is count messages kept within the budget, is at play. So 151, again, messages in the budget. So we were updating everything, managing like how many tokens a particular message has. And if it's within our limit, we're going to save those messages. And we keep a count. And once we're done keeping a count, we can place it over here. Then we can go ahead and run the whole thing, because this would show, the implementation of how sliding window is working and how the token-based implementation is working. Since our tasks are complete, we can go ahead, bring back our terminal and hit OK. Okay, so here are the details about our 2 experiments that we conducted. So the very first one, simulating a long conversation complete, we had 15 exchanges. So this is where we, keep the last 5 exchanges and we hook that up within our agent, and our agent responds accordingly. So this is a test one with full conversation, and then we do our, simulated truncated history. So that's one strategy. Then we talk about token agent simulation, and as we said, 1,000 token budget, can keep last 8 messages using approximately 88 tokens. So that's everything. Our task 2 is complete. Let's click check and move to next. Okay, and let's clear everything here. So the next couple of tasks are a bit verbose, and they are a bit longer as well. So we're going to take our time to walk through them and probably talk about it as we go. So in task 2, you learn about truncating strategies and how you can smartly manage your context. But both have the same limitation. Truncation loses information. Obviously, you're keeping the last 5 exchanges or conversations, but what if you had like the most important exchanges, at the start of the thread or at the beginning? Maybe all your preferences, your name, and your details are hooked up right there. So that's a problem. And the solution is summarization. So we talked about context engineering. So instead of you just choosing a particular bit of your conversation, it's better to summarize the older conversations into maybe 2 or 3 sentences, or maybe just identify, important parts about those conversations and saving them in a very lean and a very, effective manner. So this section is all about that. You can probably go through it. We have a couple of steps here for you. So we'll be implementing a summarizer agent specifically just for this task. So let's go ahead and do that. Okay, so we have a couple of to-dos, line 32 and 33. So let's go to line 32. Yet again, we're building a summarizer agent. I think this is something that we have done in lab 1 as well, just hooking up the name and instructions. Pretty simple stuff. Perfect. Then we have line 109, use summarizer agent to run summary prompt. So here we have the conversation topics, and this is our conversation log. And I think we're just printing all of them depending on the conversation, and with some truncation at play. So once we're done with that, let's move on here. 109. There we go. So we use our summarizer object, which is our agent, and we place our summary prompt. Okay, so our next to do is going to be on line 135, and we are on line 135 right here. Okay, so this goes here. So this is our actual summary message. So this is the summary that we have created somewhere over here. Again, as you can see, this is the response of our agent. So yeah, so we're hooking this up and we are going to use the summary message as our query with our new thread, which we created right here. Perfect. And we're using this thread below just to keep our context. And this particular thread has our lean context. So I'm going to copy this. I'm going to bring back my terminal. Let's clear the whole thing. Okay, so our task 3 is complete. Let's go ahead and check and move to the next. Okay, so in this task, we'll be talking about personalized context. So in the previous labs, we talked about how we can maintain conversation history, we can maintain our message limits, and how we can compress our context. And in this section, we'll be talking about how we can personalize the whole thing. So it's more about building user profiles, and you can go through these sections. It's pretty self-explanatory. And yeah, let's go ahead and hit OK. Okay, so let's clear this here. So we have got a couple of to-dos. Let's walk through the lab, our chat client, our chat agent. So you're a helpful agent that provides personalized recommendation. So before our agent can actually provide you recommendation, it should know your preferences. So that's what personalized context means, where we have to fetch certain parts of the data and add it into, more of a personalized context. So here we have a couple of messages. So as you can see, my name is Jamie. I'm an intermediate Python developer. I'm really interested in automation and AI. I want to learn how to build intelligent agents. So everything about these messages, they reflect, personalized preferences by a particular user. So you walk through these messages. We're going to print them here, and conversation history built. Perfect. Okay, so line number 96. So our very first to do is extract user preferences from the conversation. So we had these conversations, and right here, now we have this prompt which takes all these conversations and extract and return only JSON object with these exact values. Perfect. So line number 96, we're going to hook up our agent right here. This is pretty simple. And extraction prompt, by the way, extraction prompt is this whole thing. The prompt that extracts everything out of the, the conversations above. So once done, we move on to line 148 to 149. So this here is about create generic thread and run test query baseline without personalization. So nothing fancy, just simple stuff here. So we get agent.getNewThread. Let's copy the whole thing. And let's pass test query and generate it. So this is our test query. This goes here, and our generic thread goes here. So let's move on to line 177, inject personalized messages into thread. 177 right here. So now we have personalized messages. So this prompt goes here, and our personalized thread, this goes here. Yeah, I think we're done with everything. Let's copy, bring up our terminal, paste, and let's wait. Okay, so our task 4 is complete. Maybe you can go through all of the output and maybe reflect on a few questions in terms of, how they differ from each other, how responses are, different from each other. So with this done, I'm going to check it and move to the next section. And well, congratulations, you have now mastered memory and context. So this section is about function tools as AI agents, and we'll be talking about what tools are, how they can be depicted by functions, and how you can leverage or call third-party APIs within these functions. We'll be building a tool step by step, and we'll also be talking when tools are too much or when not to use tools. And by the end of this section, we'll briefly touch upon multi-agent workflows and task delegation among when you have multiple agents or an agentic system. So I'm pretty sure you might have used a voice agent up to this point. But what really would have been cool when you have a voice agent and it can extract, the details out of your input query and maybe, send an email on your behalf, book a cab, or even schedule a meeting, just like, Jarvis and Iron Man. So a tool for an agent is a function, API, or an external service that the agent can call to perform an action or fetch data, not just to generate, text, which is more like a limitation of LLM. We know that they're limited in terms of their training knowledge. So just like memory tool is just another add-on to enhance the capabilities for um, your agents or your simple chatbots. So I'm pretty sure you must have used a voice agent up till now. But what really would have been cool when your voice agent can really take your input query and do stuff on your behalf, like maybe book yourself a ride, send emails on your behalf, or schedule a meeting. So we know that the knowledge of LLM is limited. Memory helps to expand it, and tools is just another capability where we can enhance the internal functionality of an LLM. Or an agent specifically in this particular scenario. So a tool for an agent is a function, API, or external service that the agent can call to perform an action or fetch data, not just to generate text. So imagine you're building a trip planner, or we're just, expanding the horizons for our travel bot that we have been building since, section 2. So if I prompt the agent, book me a flight to Tokyo next Monday, I expect my agent to extract, meaningful details out of my message, which is I want to set the destination to Tokyo and date to next Monday. But now with the introduction to tools, my agent would be able to call specific functions and pass these fetch variables as parameters to that function. So that is basically called function calling, or tools for an agent. Uh, the agent would take its time, and maybe the make flight booking would return a value. And once it does, here we go. Our flight is booked, and here's the confirmation with a dummy number 12345. So this is the kind of experience we can build by introducing tools to a particular agent. So now it has a superpower to actually go and interact with the outside world and make decision based upon you. So there are two steps in which you can add your AI function. So AI function is available as an annotation in Math, and it takes nothing but name and description. You just have to name your tool, add in a verbose description, and against this annotation, what you really need to do, you need a function, just a simple function with as many parameters as you can probably provide. So in this case, this is dummy method, which takes in a location and tells you the weather, but it's very static and it's very hard coded. So we'll take this example and we'll expand it and introduce this get weather tool to our trip planner, so that if you really want to visit a particular city or a country, you can really query your agent in terms of what's the weather like over there. Step 2 would be, taking that AI function and hooking it up with the chat agent. So you get a tools attribute, and you can sort of provide your tools in terms of, an array or list of tool functions. So let's get into the code and let's build this stuff. Okay, so I'm in the VS Code with the very same example of my travel agent. Again, I've tweaked a few things. So the very first thing, as you can see, the AI function and the get weather method. So I've added a few details to it. I'll come back to it in a while. So the rest of the stuff is pretty much the same. I'm creating my chat client here. I'm hooking it up with my chat agent. Here's my list of tools, and this is how I prompt my agent. And I'm asking what is the weather in Tokyo today, and I'm extracting the reply from my agent. All right, so now let's see what I have in here. So this is a functional method. I'm basically taking in a location, and these are just a bit of annotation field, which just tells me the location is something that I need to get the weather for. So I'm using geocoding API for my weather search. The very first thing, so there are steps in which how I'm doing it. I'm preparing parameters where I just add in location. First, I need to call a particular API to fetch latitude and longitude for this location. So this is how I'm doing it, and I'm just filtering my response over here. And if I get the right response, I'm allocating it to a variable latitude and longitude. Next, I'm using latitude and longitude to fetch the actual weather for my location. And for that, I need to call in another API, and I'm preparing my parameter function, parameter object over here. And then I make this request call. And again, I fetch some data out, and the rest of the stuff I'm doing here is all about composing the right kind of response. So in this case, the city or country would be the location, latitude and longitude, which I fetched above. And from this particular call, the one I made right here, I get temperature, wind speed, and time. And I just result the response. When the LLM fetches this response, or is provided with this response, it goes ahead and formats the whole thing for us. So let's run it. So this is Python basic chat agent tools.py. There we go. So the agent replies, today in Tokyo, the weather is as follows. Temperature 13.8 degrees Celsius and wind speed is 4.1 kilometer per hour. Okay, let's go ahead and change this. Let's talk about Paris. And let's rerun the whole thing. All right, so Paris is as follows, 10.9 degrees, 4.6 kilometers per hour. So now you can see we have something functional that is, that goes beyond its internal training knowledge, and it's interacting with the world outside, and we have a pretty cool feature here. All right, so now we have a very cool agent which is updated with the outside world. It fetches us the latest knowledge for, wind condition, or the temperature in a particular city or country even. But now imagine instead of this one agent, you had multiple agents to handle your logistics around your trip. So agent A could be your travel planner agent, which would just draft a high level tentative plan given your dates and given your preferences. You could build another dedicated agent which would just go ahead and book flights for you, and another agent which would find the right kind of hotels for you. So agent A would draft a plan and pass it to B and C to do their respective jobs. So this is called multitask delegation or orchestration in some way. Let's finish up this section by talking about when not to use tools, or when tools can be an overkill. So not all agents would need full orchestration, right? So maybe sometimes you just want to build one agent, which is a simple Q&A bot. It might just need, some memory and some knowledge about, your particular topic or your organization or your company. And you can build utility functions, like convert units and, some respective small functions inside those agents. And privacy tasks first if no external call is needed. So yeah, that happens a lot of time where your agent is just more like a RAG agent. So in those scenarios, skipping tools and multi-agents keep things simple and faster to build. So yeah, if you're building out an agent, again, the very important question is, what kind of an agent do you need? You have to make sure that you're not stacking up your agent with unnecessary complexity in terms of memory and tools. Alright, people, welcome to your third lab. And your mission this time, if you choose to accept it, is to master the function tool itself. So, just like the previous labs, we have 4 progressive tasks for you, which would actually run you by the definition of function calling, how you can implement a simplest tool call through an agent. We'll talk about tool handlers and error handling and validation while you're working with agentic function tools. So let's dive into it. Okay, so we have some bit of a refresher over here. We start with what function tools are. So if you're aware of function calling or tool use, they actually mean the same thing. And later we talk about, what agents are and why agents are separate from, conventional chatbots. This is something that we have already covered within our previous videos. Uh, then we talk about how function tools work and what do they require. So in terms of definition, the kind of schema they require, we'll jump into that in a bit. And finally, we will be talking about, some of the real world use cases, and we have talked about a bunch of them before as well. So for example, in the e-commerce world, you have to search product, you have to check inventory, you have to process orders. So the LLM, which is based around an agent, doesn't know anything about your ecosystem of work. So you have to bring your ecosystem of work to the agent by exposing, certain APIs which they can leverage. And the only way an agent can leverage them is through tool use. All right, so let's click OK and environment setup. I think we've gone through this a couple of times, so I'm just gonna run through it quickly. So this just sets up my environment, checks everything is okay, and everything is okay. So I'm gonna hit check. Okay, so task 1, simple tool function. So this is more like a definition of how you define a particular tool. So you specify a type, which is function, and within the function, you have to define these attributes. The name, description. Description is very important because an agent makes a choice of calling a tool through these descriptions. And that's why, yet again, parameters are also important because the agent would specify those parameters within this tool calling. Then we have, the agent declaration, and that's how you define a particular tool. So in this example, or the very first task, we'll be building a calculator tool. So let's get started. This is our task 1. Let's make some room. Okay, so the very first to do is define a calculator tool function. So here we are. This is a method and we have an operation. And as you can see, we actually carry on arithmetics based on this operation. So if it's add, we'll add. If it's subtract, we'll subtract. A and B are, the numbers or integers here. So this is pretty simple, right? Brings back memories. So here we need to specify the return type. So I'm going to specify float here. And then for the second to do, we have to create an agent with the calculator tool. So the agent is defined. We initialize our chat client, the name, instruction, and here we have to specify our tool. So this will be the calculator. Then we have a couple of test queries and we run those test queries. Let's go ahead and run them. We're done with both of them. So let's bring back our terminal. We forgot the housekeeping, forgot to clean the terminal. Here we go. Okay, so everything is working fine. Let's clear this and click check and we're good to go. Okay, so task number 2. Let's start with it. So in this function, we'll be learn how to implement real-world tools that call external API. Perfect. Okay, so we have a weather database, Paris, London, Tokyo, and we have the respective temperature, conditions, and humidity. So this is pretty simple. So our very first to do is, so we'll be defining multiple methods, I believe, or not multiple methods. I think this one is just about, calling external API. So I believe this tool here, get weather, mimics my mock API. So this takes city and get current weather information for the city. So all the information lies right here. Let's collapse it. Okay. All right, so we get our data through our weather database, which is again some mock data. And within our very first to do, which is line number 34 right here, we have to specify a return type, just like we did in the last lab. And line 43, we have to provide a formatted string, just like this. So this returns us weather in city and its respective temperature, condition, and humidity. Perfect. So now let's collapse this. We're done with it. And finally, here we have to use the get weather tool. And that's pretty much it. Let's copy, bring back our terminal, hit enter, and task 2 is complete. Let's clear this and check. Perfect. Let's move on to the next lab. Okay, so now we're talking about multiple tool agents. All right, this is going to be interesting. So in this particular section, we'll learn how to build agents with multiple specialized tools working together. So the very first tool is, again, it's more like a mock tool. We'll be using search web. And here we get a query and we just get a mock response. So on line number 25, which is right here, again, we have to hook up our return type. Perfect. And line number 45, format and return the email confirmation message. So we have another method which we're going to use as a tool. So this gets to subject, body, and this is yet again a mock method. And here we have to specify a return type. There we go. And yeah, we're done with it. Let's collapse it. And then we have a third tool. So this is something that you're already accustomed with. We just did one. So we have an operation, we have two integers, and we carry out our operations through it. So more like a calculate method. Line number 77 is next. It's right here. And here, as you can see, to use multiple tools, you will be specifying this array of tools here. So yeah, I think we're done. We have some test queries, and as you can see, all test queries are different. So the very first one is calculate 50 times 20. The second one is search for Python tutorials. Third one is send an email to johnexample.com about the meeting tomorrow. And then we have some printing mechanism here for you. Let's paste it and run. Oh, works like a charm. And our task 3 is complete. Let's move on. I'll click check and next. All right, so we're finally on our final task. And this is about learn how to build robust production-ready tool with proper error handling. So up till now we've seen tool, but what we have missed is, the whole robustness, how we can put check. We were expecting that the LLM would put in a particular parameter within the function, but we haven't checked those parameters. So they can be problematic. Your agents can hallucinate. They can mismatch the types and whatnot. So in this particular task, we'll be assuring that whatever we get, we properly check it as a parameter. So the very first line is line number 32. Again, this is pretty much the same as previous one. So it returns string. And then on line number 43, which happens to be here, so yet again, let's walk through it. So this is query user database. And up here, we have some users. We have name, email, and role, but we don't have the ID. But this particular method actually works on ID. So we first check that if whether the ID passed here is an integer or not. That's the first step of validation. The second step is whether we have to hook this check here. So let's place it over here. So user ID is lesser or equal to 0, which means it's negative. So we have to prompt an error like, invalid user ID must be a positive integer. Then on line number 54, we have to return a particular format. So let's copy this. Here we go. Perfect. And then finally, on line number 70, we have to specify the tool, which is query user database. The rest of the stuff again is lookup user 1, valid user should succeed. We have a couple of, you can go through the test cases, and here we print those test cases. So I'm just going to copy this and run. And here we go. The task 4 is complete. We have all of our information here for you to walk through.